Similar triangle proofs. Yesterday we were talking about how to show triangles are similar, and the two ways we can show it is either by angle-angle similarity or side-side-side similarity. Given these two new geometric properties, let's go ahead and prove some two-column proofs. Given the following: proportional sides, DE to GH, DF to GI, and EF to HI, prove that angle E equals angle H. Well, let's see. What do we know about these two triangles? Because we're given the sides, we're given side, similarity, we can automatically go to the following. Triangle DEF, and make sure you line them up right. DEF is similar to GHI, and that is by side similarity. And then therefore, because those two triangles are similar, we can say that angle E is equal to, whoops, let me fix that up. Angle E is congruent to angle H by the definition of similarity. Definition of similarity. Okay, not too bad. The next one, given that HK is perpendicular to GH and that KF is perpendicular to GAF, prove that HK times GO equals FG times KO. Well, I may be a little stuck of where to start, so a strategy would be to first prove that the triangles are similar. And that's pretty straightforward because we know angle H equals angle F, which is 90, by definition perpendicular, and angle, this little angle, I'll put this a 1 and put this 2, HOK is equal to FOG by vertical angles congruent. So we go through and do these steps. Angle 1 equals angle 2. Whoops, this is number 2. Vertical angles congruent. And we really should stay explicitly that angle H equals angle F, which equals 90, and that's definition of perpendicular. And we've done a substitution step. You could do these in two separate steps if you'd like to. The next step would be to show these two triangles are congruent. Again, similar. Be careful. So let's start with HOK. And now we want to line up angle H with angle F and angle O with angle O. So we've done that. And that is angle-angle similarity. And then, now we're trying to get HK, GO. This is all sides information. So I'm thinking we're going to have to show that corresponding sides are proportional. That's where we're going to have to go here. So let's start. We have HK divided by what? Okay, HK is here, so, and that would be FG. And then what else are we given? We're given KO, right? And we have to put KO up here, and that's proportional to, okay, GO is here, GO. And that is also a definition of similarity, which are sides are proportional. And notice, right here, we can cross multiply to get HK times GO equal to FG times KO. And that's cross multiplication. Or if you want to call it, or definition of we'll talk about this in class tomorrow, but cross multiplication is really a good way to go. Okay, Example 3. Given that EF is parallel to RS, and I like to put in some markings to show that. EF is parallel to RS. Show that Fx times Rs equals EF times Sx. Okay, this is almost like the one we just did. Again, if we can show these two triangles are similar, we can show sides are proportional and then do some cross multiplication. So how can we show these two triangles are similar? Well, we have to go back to remembering what parallel lines do. They break things into corresponding. So if this is angle 1, angle 2, this might be angle 3 and angle 4. We know that angle 1 equals angle 2 and angle 3 equals angle 4 by corresponding angles congruent because the lines are parallel. Angle 1 equals angle 2, angle 3 equals angle 4, and that is corresponding angles congruent. Now that we've shown two angles in a triangle congruent to two angles in another triangle, we can say XEF is similar to XRS. So we have everything lined up right. Angle, angle, similarity. And then step 4 is to show these the relationships of the sides. So again, let's start with Fx because that's in the proof. So Fx, here it is, Fx lines up with Sx. And we have EF. Nope, Fx is over, yeah, EF is here, lines up with RS. And that is a definition of similarity. And then if we cross multiply, step 5, if we cross multiply, we'll get exactly what we need to get. Fx times Rs equals EF times Sx. And that is cross multiplication. Great. Last one. Given 1 equals 2, prove that two things, that ABC, which is this little tiny triangle, is similar to EAED, which is the big one, and then show that the sides are proportional. AB is to AE as BC is to ED. Okay, so we have angle 1 and angle 2. So we need one more angle, don't we? Do they share an angle? Yes, they do. They share angle A. Therefore, angle A has to be equal to angle A by reflexive. And now we have two angles in a triangle congruent to two angles in another triangle. So by AA, triangle ABC is similar to triangle AED. And that's angle, angle similarity. Once we have that, we're good to go with AB over AE, which is one corresponding set of sides, equals to BC over ED. And that's definition of similarity. So the next page has a bunch of practice problems. How much do they have? There's 5 or 6 of them. Do the best you can, and I'd like you to do at least 3, but look at all of them, and we will go over these next class. At least mark up all of them. In other words, mark up the givens and see what you can. Maybe you can finish it.